Classic Studies in Athens. Claudia will be speaking on the conservation of the Iwo Jima Monument, Parris Island, for the United States Marine Corps.
Although apparently it says on the lead slide there, Iwo Jim. How did that happen? Thank you so much, Debbie, and thank you to everyone from NCPTT, Mary, everyone for doing this amazing conference. And there it is, Iwo Jim, how awful. It's such a great topic. Paul and I work a lot with military heritage, and we always talk about, oh, we'd love to have a conference, and then boom, it happened. So thank you so much. I've just been really inspired by the talks, and I wrote down a few things here that I wanted to share. The human element, the stories, the people behind the objects. In this case, the photograph, the man behind that photograph, was really inspiring to us as we did the conservation and the restoration of this very difficult sculpture. And of course, it's the anniversary of D-Day, so I was thinking about Second World War even more this morning. The United States Marine Corps War Memorial, also known as the Iwo Jima Memorial, is the very well-known monument to the United States Marine Corps, which was sculpted by artist Felix de Weldon, and that's located in Arlington, Virginia. The monument represents 6 Marines raising the flag of the United States on Mount Suribachi, and everyone's seen that iconic photograph from the Second World War. This was revised in 2016, formally by the Marines, because there was formerly 4 Marines and 1 Navy corpsman, 5 Marines and 1 Navy corpsman, and this was revised in 2016 after review of historic documentation. So we were thinking, oh, our report for this project has the wrong names in it, but that was submitted before that official change was made. The monument is a depiction of the famous Pulitzer Prize-winning photograph by Associated Press photographer Joe Rosenthal. You can see that iconic image on the right of this slide. It's now in the public domain, so you can get copies, use the photograph after all these years. The second flag raising on Iwo Jima was one of the most documented events in Marine Corps history, and so compelling an image that it was chosen by them to represent that past and their sacrifices in the memorial. I included this photograph. This is the bronze Iwo Jima Memorial in Arlington. The photograph at the bottom of the slide just shows you the scale. It's a huge 32 feet or 78 feet with the flag. Born in Vienna, Austria in 1907, de Weldon was already a renowned sculptor in Europe before he immigrated to the United States in 1938. He enlisted in the Navy during World War II, serving as the official artist for naval aviation for the war. While serving at the Patuxent River Naval Air Station in southern Maryland, de Weldon viewed a photograph of the flag raising at Mount Suribachi. The image captivated him so much that he began sculpting a model that day the photograph was released. Later working with the 3 surviving soldiers from the battle, Rene Gagnon, Ira Hayes, and Harold Schultz, to model their faces in clay. In this image on the right, that is de Weldon on the left, at the memorial after it was dedicated. On the right, you can see him with Rene Gagnon in the photograph, and he's doing the sculpting of a head. You can see the scale of this thing. His work ultimately produced the 30-foot-tall Marine Corps War Memorial in Arlington, Virginia, which is visited by an estimated 1.5 million visitors each year. But before all of that, de Weldon produced several smaller scale models of the future bronze. The original 1/3 scale model was sculpted in de Weldon's Washington, D.C. studio in 1945. A plaster mold was made from that model to produce additional sculptures in concrete. Only 3 concrete versions of versions of the sculpture survive. The first and original of the 3 was previously exhibited and is now believed to be in storage. That version belongs to the Wall Museum, which is a virtual online museum run by Rodney H. Brown in New York. It does have a website where you can see the original version on there. The second is known as the Iwo Jima Memorial and is the subject of this presentation and on this slide. This sculpture is what you see on this slide and is located at the Marine Corps Recruit Depot, Parris Island. The third is at Cape Coral, Florida. One additional version exists at the Marine Corps Base Quantico. That would be 4, but this one was based on the original model but carved in limestone, not in concrete. The concrete version you see here is the 1/3 scale model of the bronze. Oops, that is extremely sensitive, as everyone said. And it was made of, it's a 1/3 scale model of the bronze made of steel reinforced concrete set into a concrete base. It was erected on the Parris Island Depot Parade Ground in 1952 and dedicated in September of that year. The bronze was dedicated in 1954, so this is 2 years prior. Shortly after the sculpture was exposed to the environment of Parris Island, it began to develop cracks and fissures, allowing water to penetrate the concrete and saturate the clay core. I will explain the construction technique shortly on a future slide, but basically it is a concrete shell filled with a type of clay reinforced with steel rebar. Previous repair campaigns have been carried out on the sculpture in attempts to address the water ingress into the monument and prevent cracking and breakdown of the coatings. You can see a little bit on this slide. It was not possible to do justice to what we could see, but I included a few close-ups just to show the number of coatings we could see. There ended up being 11, but I'll show you that when we do the coating removal section. There was clay coming out, it's staining the surface. We had salts, we had pretty much every problem. These previous repair campaigns began as early as 1956, 4 years after the sculpture was dedicated. In 1961, the sculpture was coated with a, quote, preservative epoxy paint, and in 1964, repairs called for reinforcement of the statue with a, quote, stronger than steel material. Most probably a polyester-based auto body filler like Bondo that you would use on your car. And it was finished with a, quote, permanent covering that would enable the monument to stand forever. In 1972, more repairs were carried out. A bronze-coloured lacquer coating was applied, which you can see here. It was originally green, we think to represent bronze, a corroded bronze. The concrete was actually painted green. Again in 1998, another repair campaign using a 2-component epoxy grout. These are documented in The Boot, which is the Marine Corps magazine. The surface was coated with thicker and more impermeable coatings in an attempt to fill the cracks and stop the deterioration, which was constant. The cracks were filled with various patching materials, including polyurethane foam, polyester resin, different kinds of cement, wood, and cork. We found all these materials during the restoration. Unfortunately, it didn't work. I should point out that the sculpture, we believe from our research, was made for the war bond drive to raise money for the war. You know, because the photograph was sent all over the world as it could happen at that time. They were not in the digital age then. And so raising money was extremely important. It raised a huge amount of money, but this sculpture was not supposed to last, but it was given to the Marine Corps and put at Parris Island. And so now we have an object that was, as other people have talked about, not supposed to last, not made of materials that would necessarily last like the bronze. So what do we do with that? When Paul and I first looked at the sculpture in 2014, water was dripping from several areas and the surface was completely wet. If any of you have been to South Carolina, you'll know what I mean. Probably a lot like Texas, actually. Another conservator had also looked at it a couple of years before us, and she took core samples, and these were completely saturated. In 2014, Paul and I were contracted by the depot to undertake a technical inspection of the monument to assess its structural condition and provide recommendations for treatment. X-radiography, 3D laser scanning and visual inspection were performed, and a team of X-ray and 3D scanning specialists did that for us from Jan X-ray Services, Crayoform, and a structural engineer from Bennett Preservation Engineering. The 3D scanning was employed as the Marines wanted an option to produce a new sculpture if this one proved to be beyond repair. You can see some of the X-rays going on there, and the 3D scan, the output from that is at the bottom. I don't think they'll ever use this, but they wanted to have a sort of backup. The X-ray was not an easy undertaking owing to the thickness of the sculpture and its geometry. The results indicated that the sculpture was suffering from advanced deterioration, and this agreed with our own detailed visual inspection. Severe cracking of the concrete was clearly related to the corrosion of the internal steel armature and continuous infiltration of water, made worse by the application of the impermeable coatings, which prevented the escape of moisture from the saturated concrete. So these are some of the images we could see. What we could use these for as well was measurement of the rebar, so we knew what we were dealing with. On the left is the foot of Ira Hayes. This was one of the worst areas. There's cracking visible in that X-ray. This is a patch along the side here that we ended up repairing, but there is further up in the image, it's not on this image, but there were worse cracks. This is the head of Block. Block is at the front of the group, and he didn't really have much wrong with him owing to his position in the group. He's bending down at the base of the flag, so the water runoff was much better for him. You can see the helmet, you know, it's hollow. This is the top where the hands go onto the flagpole, and so we can see that some of the rebar is broken. It's in small pieces. It's sort of like a jerry-rigged sculpture in many ways to get it ready to take on the bond drive. It's not produced in a way that would suggest that it was supposed to last for this long. So these are, apart from Block, the Hayes was one of the worst, and also the hand area was of major concern to us because there were so many visual cracks in the hand when we started the work. This is just a mosaic that the guys put together for us so we could quantify to the Marines what exactly was going on. Areas marked number 1 on this slide were the worst condition. 2 were probable corrosion. We couldn't see because the X-ray wasn't good enough. It was a difficult thing to X-ray. There was an iridium source. More about that is in the paper. But they did a pretty good job, enough for us to get an idea what was going on. And all of these areas ended up being opened up. At first it was only a small group, and then we had to open all of them because they were all connected. We created this X-ray map to visually indicate where we thought the sculpture had to be opened up for treatment. And as I just explained, the red squares are high priority. The yellow was less high priority, but still problematic. Ultimately, 71 areas were opened up. Based on these results, a major restoration campaign was undertaken in 2015 to 2016 to stabilise the sculpture. This team was carried out by a large team of conservators and other people from historic restoration and industry, including conservators from Conservation Solutions, which is now Evergreen Architectural Arts, coating specialists from Ultra High Pressure Projects, and Kime Mineral Pigments, a structural engineer from Bennett Preservation Engineering, and construction support from Sierras Construction. The main goals of the restoration were to re-establish the structural integrity of the sculpture, reduce the rate of future deterioration, and preserve as much original material as absolutely possible while respecting the memorial's artistic and historic significance. You can see most of the steps on this slide, so it was a multi-step treatment, including taking off the coatings first, removing the concrete shell, removing the wet internal clay, replacing or mitigating the severely corroded rebar, rebuilding those excavated areas, patching the surface crack injection to prevent water getting in there anymore, repairing of the flagpole, which was also a big problem, and application, very importantly, of a new breathable coating system. We also tested the concrete for presence of asbestos and lead because we were worried about that, and that proved negative. So we began with the coating removal. There were 2 separate phases of this. In the first phase, we used a water-based paint remover to get those 11 layers off. This was Sea to Sky. The details are in the paper. The name of it is Sea to Sky. And it was applied in numerous sequences because the paint was so thick, and then it was washed off, scraped off and washed off by a pressure washer. The 11 layers indicated to us, it was more than we expected, that no paint removal had probably ever taken place. They just kept repainting it and repainting it. And a lot of the work was done by the Marines. We were told by some of the officers that took an interest that they would send them there to do repair. It was like punishment, sort of. They had to polish it, put the coatings on, etc. After paint removal, a thick impermeable coating still remained on the surface, as you can see in this slide. This was originally thought to be the surface of the concrete as it was painted green, but was actually a thick combination of polyester and epoxy. This triggered a second phase of coating removal. You can see in the right-hand slide there, right-hand photograph, it even filled patches. So there was massive holes, patches, cracking. This is probably from the manufacture or fabrication of the sculpture, but there were other areas that we just couldn't understand why there'd be a hole there. Probably it cracked during this. It was put on the back of a flatbed truck and trucked around the United States, so you can imagine what happened to it. This coating removal phase was done by wet blasting using recycled crushed glass. About 1.2 tonnes of fine glass media were used, and approximately 95% of the coating was removed. In some areas, such as deep recesses, undercuts, and in places where the coating was extremely thick, it had to be done mechanically afterwards because we didn't want to remove the surface of the concrete. We tested this on numerous pieces that were already removed from the sculpture so we could get the optimal distance, pressure, etc. And it was extremely hard. It was just awful. So this is how it looked after coating removal. You can see some of those pockets still remaining, which we could not really get into. We had to mechanically take those out. As indicated by the X-ray survey and visual assessment of the surface, after all coatings had been removed, 71 areas needed to be opened up. And we were asked to give a per square foot estimate, but it has volume, this sculpture. It proved to be absolutely difficult for us to do that because one area was related to the next, and it was really hard to do that. So we ended up joining a lot of areas together, and we had to do that in order to access the rebar. The internal core and rebar were accessed by cutting through the concrete outer shell using a diamond blade fitted to electric grinders. Registration marks were made on the sections that were removed so they could be reattached in their exact location at a later date. These processes were documented by field drawings and photographs. And you can see Joe and Seth from Conservation Solutions starting to open it based on the X-ray, the areas that we had indicated needed that work. This was not an easy process, as you can gather from the images, owing to the geometry, and on some parts of the sculpture, it was just really difficult to access. The sculpture appears to have been fabricated by packing clay around a welded steel reinforcing system to which the prefabricated concrete shell was attached. A green pigmented mortar was then packed around the clay and rebar system. And you can see that in the slide here. Galvanized steel mesh was placed on top of this layer, and then another layer of green mortar. The concrete shell was then attached to the rebar and clay form. Wood, polyurethane foam, and other materials were found inside the sculpture when we opened it up, but we were unclear if this was used by De Weldon just to fill areas, or it was the result of a later restoration effort. The shell, approximately 1 inch thick, was likely fabricated by pressing the concrete into a mold, allowing the sections to be as lightweight as possible, because you can imagine how heavy this is. especially putting on a truck, taking it around the United States. This is the left leg of Ira Hayes at the back, one of the worst areas. So you can see on the left of the slide, opening up that area. Gradually, the clay was removed in the center image, revealing broken and corroded rebar in the third image. I should also point out that when we opened this part of the leg, near the foot, water actually flowed out from being trapped inside, like gushed out. It was kind of insane how wet it actually was. Once sections of the shell were removed and the internal clay exposed, these areas were excavated using pneumatic chisels, hand tools, and pressurized water. Corroded sections of steel rebar were then accessible once the clay core was removed and we could really see them. This is the leg of Harold Schultz. Moderate to severe corrosion was visible on the majority of the accessible rebar. In parts of the sculpture that was particularly wet or damp, particularly the feet, because all the moisture was running down to the feet all the time, and the lower legs. Rebar showed extreme levels of corrosion with more than 50% of the bar thickness reduced. You can see this on the right image, which is the left leg of Schultz. Rebar that were embedded in the wall of the concrete shell for structural support were often completely disintegrated. Some sections of rebar simply fell out when we opened the sculpture. You can see the really thin section there. That was a probably 1-inch rebar. Corroded rebar armature was removed with a metal cutting wheel and replaced with new fiberglass rebar of the same approximate diameter. We use number rebar rods 3, 4, and 5, and I've given the measurements of those in the paper for those that are interested. The new rebar were lapped onto existing rebar with nylon zip ties, and you can see Paul doing that here in this image. Where the rebar were in direct contact with the concrete shell, they were reusable. They were secured to the shell with a structural epoxy. Lapping extended to approximately 12 inches in each direction where feasible, and the new fiberglass rebar were lapped with existing rebar in adjacent areas of the sculpture for maximum continuity. All replaced rebar were assessed by structural engineer Craig Bennett to ensure that they were correctly attached and structurally sound. We were concerned about that because we could not open all of the sculpture, so sometimes we had to lap it onto pieces that were already there, but we made sure that those pieces were not to be replaced. They were fine. Nothing was lapped onto something that looked like, in the future it might have kept corroding. But of course that's a concern of ours because we didn't open the whole sculpture. These are just more pictures of the rebar being replaced in the right leg, left foot, and the right thigh of Ira Hayes. He was one of the worst because he's at the back of the sculpture. You can see Paul there pulling out. I mean, that rebar just basically fell out. Some rebar were not replaced as they were embedded in the concrete shell or were judged to be corroded to less than 50% of the bar thickness. These rebar were mechanically cleaned with steel brushes, pneumatic chisels, etc. Some were blasted with fine crushed glass and coated with 2 coats of Mapifur, which is a corrosion inhibiting mortar. That's also in the paper. And you can see that here on the top right, that purple coloured coating, that's the corrosion inhibiting mortar. After treatment of the rebar, all excavated areas were treated with Cortec, Migrating Corrosion Inhibitor 2020. And this is designed to penetrate through cementitious materials, including concrete and mortar. We put this everywhere, including all parts of the sculpture which were not opened. It's targeted to go in and reach the rebar that we could not reach. The base of the flagpole was also an area of major concern due to the stress removement of the pole. After removal of the lower set of hands belonging to Sousley and Gagnon, the base of the pole was found to be extremely corroded and poorly secured to the sculpture. The pole is actually attached into the lower back of block, and then it's connected to smaller rebar in his back and down into the legs. The pole was cut from the sculpture about 10 centimetres from the bottom, blasted with crushed glass to remove the paint system, and this was also treated with the Mapifur corrosion inhibitor. The interior of the pole was filled with loose corrosion products, and they were taken out, and that was cleaned. It was then reattached to the sculpture with 5 pieces of number 3 rebar, which were grouped together for structural support. This was 2 feet in length. It was secured in place with structural epoxy. And then Craig Bennett is our engineer on this project on the left there, and he's advising us on that before we cut the pole. After the clay had been removed and the rebar treated or replaced, the voids within the sculpture were refilled. Some areas that required more detail were sculpted first, such as the helmet of Hayes, which was not correctly sculpted to start with, did not have a visor, so that had always bothered the Marines. So here Mark Rabinovich is actually resculpting that based on the original dimensions. For rebuilding, the rebar were first encased in Planetop, and that is a polymer modified repair mortar, which has an added corrosion inhibitor. So anything right around the rebar was sort of molded. This was molded around that area first. And then the voids were filled with a concrete mixture consisting of 1 part type N cement, 3 parts sand, and 3 parts pea gravel. The concrete was either poured into the voids formed by the reattached fragments or built up in several lifts. This is, again, the leg of Hayes. He got a lot of photographs, Ira, because he was right in the area where it was easy to photograph with the light of the sculpture, because we had a scaffolding and full cover. We couldn't do this in public because it was very stressing to them to see a sculpture like this. We had a vision of how this was going to look. It was not necessarily shared by the Marines because they didn't understand how we were going to get this back together. So we kind of had to do it in the scaffold, which was fully covered. After all interior treatment had been completed, the detached pieces of the concrete shell were reattached in their original locations and orientations, and you can see that happening here. And again, this is the leg of Hayes. And this is after building up that leg and after doing all the fills. It's not quite finished at this point. You can see the knife there. Has to be remolded as well and put back. There was a piece to go back, and then it had to be slightly remolded. The sculpture is not as fine as the bronze, you may say. So some of the detail was lost when they made it in concrete. Just some other photographs after filling of those areas. We found some things during the restoration that were really cool. One was the signature of De Weldon, which had never been visible because it was totally covered with paint. So they were really happy to see that. It's dated 1945, so our research was correct. Then started the coating sequence. This was complex and numerous coatings were used. The sculpture first dried for a period of 10 days to ensure the maximum cure. And we had to construct an enclosure to do environmental controls for RH and temperature, so the coating sequence could go on in the correct fashion according to the manufacturer's recommendation. A Keim solderlit coating system was chosen for Iwo Jima due to its compatibility with the substrate repairs and restoration mortars used. Keim coatings are based on a combination of silica sol and potassium silicate binding agents, so they're really appropriate and breathable for concrete. The Keim system is also light, fast, and UV resistant, and these were important considerations because the sculpture is right on the parade ground. He's in the sun all the time and all the weather. I included those details in the paper as well, but the sequence was 1 coat of Keim concretal. The surface was then de-limed. 2 flood coats of Keim Silane 100 water repellent were applied, and then 1 base coat of their product, which is called Solderlit, was applied by airless sprayer. That's what you see going on here. The last part of the coating sequence was to put this metallic finish. We gave the Marines a choice, and they chose this colour. So it gave this sort of slight sheen. We preferred a different choice, actually, but it was up to them. Here's the unveiling of the sculpture. They had a little ceremony, which was really moving. They put the flag back. That's the sculpture after restoration. I should add that the plaque, which is on there, is now being replaced to reflect the correct names of the Marines who raised the flag. And it was a large team of people. This was a photograph taken with the Commanding General Williams on the left, very extreme left. He took a really close interest in this, and he asked for permission to come and look at it. And we said, sure. I hope he's going to be ready, because as Paul kept saying, it felt like open heart surgery. I mean, the whole thing just looked, and we don't like people seeing objects when they're in that state, because as conservators, we know where it's going to end up, but it's not necessarily something they can envisage. And this means so much to them, this sculpture, even though it's made out of materials that weren't meant to last. Everyone, even Mary told me this story with her son, everyone has their photograph taken at this sculpture when they graduate. Families get photos there. All the two former Marines came to the sculpture one day and asked for permission to look at it because they had disembarked from Vietnam, of course, from Parris Island, famous for that. And they wanted to have another photo because they had a photo of them next to it when they disembarked from Vietnam. So we said yes, but it looked like, it was totally open up at the time. So the meaning is there, even though the object is from materials that we don't think should last. Thank you.
Thank you, Claudia. We have time for a question. Does somebody have a question?
When you were working with these materials, the refilling and then covering back up and all that, did you have to do any sort of climate control within the scaffolding to make sure that that was like an optimum level for all these things to cure and whatnot? Or was it just whatever South Carolina was at the time?
It's a good question. The real environmental controls were put in for the coating system because it's very specific. Prior to that, we didn't really have specific control. We did this in the winter, so it actually gets pretty cold there, believe it or not. Not cold like the north, but cold enough for us to keep, to work. It was perfect temperature, actually, for that work. But the real controls were for the coating system because they're very specific. So we didn't do that until the last 2 weeks. Before that, we had pretty cold weather, actually, and it was perfect for the concrete. So it was a concern of ours, though, yeah.